I did a fantastic job of what?
After teacher said that say solve the question, I understand why.
Yep.
It is successful.
Thank you. Alright, let's have a look at the homework then. You got any of the questions? 0? 1? 2? 1. First one?
Yeah, first one. First one and no answer.
Let's have a look. So,
For me.
okay. Right. So, now,
So it didn't open.
oh. Huh? Turn on.
Turn it on.
Yes. Come on. Is it, can you hear it? Is it on?
I hear something outside.
Yes, that's outside, Grace. Come on. That's what I hear when you talk. Not just you, all of you. Okay. Here we go. So, I know some people drew the first one a little differently. Don't worry if it's a little different to mine, because in the exam I'll give you a picture. Okay? But the way I was picturing this was like this. So you have this hanging from the ceiling, and this was 50, and this was 40, and this was 50 kilograms. So the way I see it is that there are three forces. There's this one going down here, which is 50G, but these must also go towards the middle. So you could draw the force like this, which is one way, and sorry, like this, which is the other way. So if that's 40, this here is 40. So you can say that this one here, if I call this one T and this one S, this is T cos 40. This is T sine 40. No, it's not. That's S. S cos 40. S sine 40. T sine 50. And then this one here, T cos 50. So there's this to the left, this to the right, this to up, and this down. So because it's balanced, you know that sine 40 S plus sine 50 T, what must that equal? That should equal,
W.
yeah, W, 50G. And you also know that cos 50 T minus cos 40 S should equal 0. Sorry, I wrote that backwards. I wanted the S to be first. So you can have cos 40 S minus cos 50 T should equal 0. Basically that cos 40 S equals cos 50 T. But the reason I wrote it like this is to make it like two equations.
So cosine is equal.
Yeah. Cos 40 S equals cos 50 T. This equals this, makes this. Yes? Can I go down a little bit here? Right, what's sine 40? Sine 40 is, so you have 0.6428 S plus, and here's a minus, sine 40 is the same as cos 50, 0.61218 plus 0.7660 T and 0.7660 S. this equals 0, and this equals 50g. 490.5. Now, how could I solve this? Well, one thing you could do, yeah, you could multiply this one by 0.6428 and multiply this one by 0.766.
Why?
And then these will become the same. Because if you multiply this by this, it's the same as this one multiplied this one. So these will be the same. And then what you do next, you add them, and then what happens? They cancel, and then you're left with an S, and then after the S you get the T. So I'm going to pretend I did that. That's not difficult, that's just basic maths. So when you do that, you'll get S is 315.3 newtons, and T is 375.7 newtons. Did anybody get that?
I got 381.5.
And the other value?
760.
Oh, it sounds okay to begin with. So there's some mistake in your work. Grace?
No.
What did you get?
Because I didn't know that they would
No answer?
connect in the middle.
2. Only 2. Not 1.
Oh, you got question 2.
Yeah.
I see. Yes?
I didn't know they would like connect in the middle. Never mind.
Never mind. Okay, the next one?
So,
Alright.
Yes?
T cosine 50 is equals S cosine 40.
Cos 40s equals cos 50t.
This is the same.
Yes.
And
This is the same. Yes.
Okay.
Yes? Are you sure?
I'm not happy. I'm sure.
You're not happy, but you're sure.
Yeah.
It will do. That's the best I can hope for.
Thank you.
Yes. Alright, next question.
Yes.
So this is the one you got, Grace.
Yes.
Yes.
I understand.
You understood it. 12 kilogram rod of length 1 meter is hung by means of 2 1-meter strings. Each string is attached to one end of the rod, and the strings and the free ends are attached to the same point on the ceiling. So what's happening here? You've got your 1 meter rod. What's the mass of it? 12. So there's a 12G here. Yes? And there's 2 strings attaching it to the ceiling. And there's forces here of T and forces here of F. But I know that they must meet at the same spot because there are 3 forces in total. So I know they all must meet here. So we also know that each string is 1 meter. So this is 1 meter, this is 1 meter, and this is 1 meter. So these angles must be the same.
Yeah.
Because they're not only 1 meter, but also because of the 3 forces. So I think it's quite clear what angles these must be. 60, 60, 60.
So this 60 is just a guess?
Oh no.
Oh, you're trying. Okay.
Yes, yes, yes.
What is the English name of this special triangle?
You will do that with Roland very soon. But it's called equilateral.
Equilateral.
Yes. But you will do that with Roland. Okay. So here, I'll do it in red. This one is T cos 60, and this one here, T sine 60, and here, S cos 60, and here, S sine 60. Now, if you look at this, you can say that this one must equal this one. The left and the right must be equal.
Yeah.
But there's cos 60 in both. So then you get T must equal S. Now, if you look what's up, you have T sine 60 plus S sine 60 must equal 12G. But remember, T must equal S. So you can say 2T sine 60 equals 12G. Divided by 2, divided by sine 60. So you get T and S, they both must equal 67.97. So we'll just say 68, will do. About 68. About 68 newtons. Is that what you got, Grace? Fantastic.
Yes.
I don't know the Chinese for congratulations.
恭喜
Gongxi?
恭喜发财的恭喜。恭喜 is just congratulations.
It's like Happy New Year, is it?
No.
No, okay.
Happy New Year is 新年快乐。
Okay. Right. How did number 3 go?
No.
It didn't go? Where do you get these yogurts? From home?
Yeah.
Homestay. Homestay feeds you well.
Easy.
Yeah, they give you good food.
Well,
You know?
every day is good.
Good, yeah.
I hope every day is good.
Oh, you hope every day is good. Okay. Ah. Next question? Ah. Yeah. Number 3. Nice question. A 10 kilogram cylinder of radius 10 centimeters is dragged over a 4 centimeters barrier by means of a horizontal force. Good question. So this is number 3. So this distance here is 0.04 meters. Okay? And then what you have is a big cylinder. And it's being dragged across here by a force F. And what will happen is it will roll over the wall, of course. Think about it like a car that's driving over like a little curb, a little bump, yeah. There are 3 forces on this. The first force is the F, of course. The second force is the weight, which is how much? 10G. And what's the third force?
The cylinder.
Yeah.
Rely on
The reaction between the cylinder and the wall. And we know that that must be going towards the center here. Now, somebody might say, well, what about between the ground and the cylinder? Like, shouldn't there be a reaction going up here as well? Well, not really, because it's just, if I can try and draw it a bit better, it's just left the ground. It's not in contact with it anymore. And it's beginning to travel over the wall. So there's actually, if you want, no contact here. It's just at the point of going over. Yeah? Right. So let's put in some distances. So this distance here, how big is it? How big is this? You know how big this is?
Yeah.
It's 10.
Yeah.
The radius is 10.
Huh?
Why?
Doesn't it say?
Is that at the beginning?
Where?
There. Do you know this word, Amanda?
But why is the force is 10?
The force is 10. Oh, 10 kilogram. 10.
Can I see a picture? Oh, here.
Yeah? It's like, here, look, this is the cylinder.
Uh-huh.
This part here is 10 centimeters,
Yeah.
and its mass is
Yeah,
10,
yeah.
so it's 10 g, and it's rolling along, and there's a force pushing it, or if you want a force pulling it,
Yeah.
and there's a little wall, and it's pushed until it goes over. You know? Yeah? Okay. So, we know why that is 10, 0.10? That's the radius. Okay. How big is this? Here to here?
0.0 radius.
0.04. Sorry, I meant to make it the same height as this.
Yeah, yeah.
Ah.
Yes?
Yes.
So how big is here to here?
0.06.
0.06.
What? No.
Yeah?
How is that? Okay. Fine.
True? Agreed?
Yeah.
Yes. How big from here to here?
It is, you have to use thing.
Ting, what's the guy? Ting guy. Name the guy, tingy fella. What's his name?
Pythagoras.
Pythagoras. So you get 0.08. So if you look at this triangle I drew, this is 0.10, this is 0.6, 0.06, and this is 0.08. So do we know this angle?
Yes.
We sure do. The angle is tan inverse 0.06 over 0.08. So you get theta is 36.87 degrees. So do we know this force, the or here, this will be or sine 36.87, and here, this one here is or cos 36.87. But or sine 36.87, what must that equal?
It has to equal 10 g.
Correct. So then or equals 10g divided by sine 36.87. So you get or must equal 163.5 newtons. But or cos 36.87, what must that equal? F. So now we have our answer for F. Yep.
Where is 0.06?
Here to here. Okay.
Yes.
I can stop?
Yeah.
Yes. So the or, here's our answer, or equals 130.8 newtons is our answer.
I thought you already found R.
Sorry?
No, F.
That's an F, not an or. Thank you. F equals 130.8.
Why 0.08?
Pythagoras.
We know 0.1 and 0.06.
You know 0.06 and 0.10,
Yeah.
so you can know this. Or what's it in Chinese? Go go di? What's Pyth? That's it. Yes. I need to learn this in Chinese. What is it? Go.
G-O-U.
G-O-U.
G-U.
G-U.
D-I.
D-I.
N-G.
N-G.
Yeah.
Up, down, flat.
No.
N-L-I.
N-G-L-I. No.
What? Start again.
For
D-I-N-G.
pronunciation.
D-I-N-G.
Yes, and
L-I.
Oh wow, okay. So this one, flat,
Flat.
up,
No.
down,
V.
V,
Down.
down,
V.
V. Gao, gu, ding, li.
Go.
Okay.
Go.
Go, gu, gu,
Yeah.
ding, li,
Ding.
ding.
Ding. Just you say the pronunciation a little long.
Ding.
Yeah. Ding.
You're better at this than me. Alright. Well, you know him. He had this.
Yeah.
Yes. Pythagoras is the same in Arabic, isn't he? It's Pythagoras in Arabic, isn't it? Or Malaysian or...
It's still Pythagoras here.
And Korean, is it still Pythagoras?
Yes, Pythagoras.
Pythagoras, yes. So you know who I mean. Okay, you have this?
No, no, no.
Oh, okay. Did anybody get this right?
No.
Oh.
Because picture is hard to draw.
Picture is hard to draw? Yeah, okay.
It's so hard to understand.
Yes.
The picture, the words to the picture.
Where's
I mean, it's because, like, in a question
Where's or? Sorry, or is here.
in the question, the cylinder is at the point of tipping over the barrier. Find the force F required to tip it. I thought it meant the barrier was gonna tip over.
Okay. That will be much more difficult to do. Now in the exam, these questions do have diagrams, but not every question has a diagram. Only some of the questions do. Like the questions in section B usually have a diagram, but not always in section A, the shorter questions. Yeah.
Cylinder is not mean the shape like the bottle.
Yeah.
Just two circles.
Two circles, yeah.
Yeah, but
Oh, but
which is cylinder in this picture?
I'm looking at the cylinder like this, not like this, like this, and it's rolling this way.
Which way?
I'm looking at it like this. Here's the ground, here's the cylinder on the ground, and here's the wall, and it's going over the wall.
So we see in the
Different angle. Yeah. Wow, that's messy. Yeah.
Where's F?
What? What's F?
Oh, F is.
F was there.
Yeah, yeah.
Alright. Can I continue with the last one?
Okay.
Are you sure?
Yeah.
No, Grace doesn't look sure.
Okay.
You are good?
In this force equal this force and this force equal this.
Like normal.
Okay.
Yes. Alright. 10-meter ladder, 20 kilograms, 8 meters from the base. Okay, so how did number 4 go? Did you draw it?
Yeah.
Ground, wall, ladder. The ladder is 8 meters from the base, and it's a 10-meter ladder. So this is 10 meters, and this is 8 meters. So, if we use Gao, Gu, Ding, Li, we can get this height here. How much?
6.
6 meters. Right? Yeah. How many forces are here? Well, there's 3 forces. There is the weight, of course, which is 10G, is it? No, 20G. Now, the wall here is smooth.
But
Yes?
the person said
Yeah.
the lander is 8 meters from the base.
Yeah.
Base is not from the ground?
Here to here is 8.
Oh no. From here, from the base of the wall, it's not means
You think 8 is here?
Yeah.
Yes, no, this is an English thing. I'm sorry. But when you talk about ladders, and you say the ladder base is 8 meters from the wall, you always mean on the ground.
Because if I just see from the base.
Now, I completely understand, because last week, when we were doing these questions, I talked about the sign being 4 meters from the base, and then, that would be like here. Completely understand. In English, when we talk about signs, we're measuring on the vertical, the base. from the base.
Yeah.
But when we talk about ladders, and I say the ladder is 8 meters from the base, I always mean on the ground.
What is this base of the world?
Yeah.
Yeah, I know. This is the base of the wall, and when I say the ladder is 8 meters from the base, I mean it's 8 meters out from the base, not 8 meters up from the base. Now, if you want
Eight meter from the base.
yeah, if you want a better explanation, you can ask your EAP teacher.
EAP.
Yes. Yes. So you can ask him or her. Who's your EAP teacher?
This is it.
Jenny,
And Connell and.
You can ask one of them.
Okay.
You can ask them to draw this picture, and I think if they draw it, they would draw it the same as I did, 8 meters here to here.
Sure. If they draw the picture like us, what should you do?
See, I would really like to see what they draw. Now, ask Connell first,
Yeah. Why is Connell?
because I think he will get it right first. Yeah. Anyway, if you did 8 the other way, that's okay. The method will maybe be the same. Well, did everybody do 8 the other way? Did everybody draw 8 on the
I
wall?
thought it was 8 on the
Did
wall.
everybody?
I
8 this way and
Yeah.
6 this
Because
way?
You say it's all
from the base of the wall,
Yeah.
like the wall is here, so the base is here, so you would automatically assume that it's 8 meters, right?
Would you? Because if I walked in and asked the biology teacher right now, I'm willing to bet.
Maybe he didn't think very clearly about the question.
When you're at 50, he would draw it this way too. Why don't you ask your English teacher and see what happens, okay? But I understand why you all did 8 on the vertical, because that's what we did last week with the signs. Do you want me to do it the other way around to see if you got the same answer? Will I put 8 on the vertical and 6 down below? It really doesn't matter. Will I do it the other way?
It's okay.
It's okay to do it this way?
Yeah.
Alright. So the wall is, you see here, this is an important word, smooth wall.
No reaction.
Yeah, well, there is a reaction, but a very special type. The reaction here is perpendicular.
Only.
Perpendicular, if it's smooth. Do you remember we talked about this, that there's no vertical force? Yeah? But here it's not smooth. There is a horizontal force holding the ladder on the ground. What's this force called here? Friction, yeah, or drag or whatever. So we'll draw this one at a bit of an angle, and I'll call it S. Now you know where they meet. They all must meet up here.
S is the reaction force.
Yeah. Reaction. So they all must meet exactly here. Yeah? Could we work out this angle? Could we work out distances? Yeah. Well, let me write the distances in. Are you ready? Yes?
Yep.
So how big is it from here to here? 4, yeah. And here to here? 4. Now if I go across here to here? 3. And here to here? 3. And here to here? 4. And here to here? 4. Yes. And here to here? 3. And here to here? 3. Now this one goes all the way up to here, right? So if I draw this triangle in here, let me just draw it again here. How big is this part? 4. How big is this part? 6.
Alright.
3 and 3.
10.
You can, Pythagoras,
Is it 10?
I believe it's 10.
Let me check.
No, sure it's 10. No, it's not 10. It's not 10. Square root 36 plus 16, it is 7.2, it's 2 root 13. Do we know this angle?
Yes,
We can know it. So if I calculate the theta here theta equals tan inverse 6 over 4, tan inverse 3 over 2, 56.31 degrees. So you can have here, if I draw it in black, S cos theta, and here S sine theta, and here's our S. Right, so what does S cos theta equal? That must equal or. And what does the S sine theta equal? That must equal 20g, yeah. And we know the theta, so if I put that in here, I can get, can I get anything? No, I need to put them together, don't I? Or something. Oh, here, no, sorry. I should put it in here first to get the S. S equals 20g divided by sine 56.31, 235.8 newtons. And if I put that in here, I can get the or. So I get 130.8 newtons. Now let me have a look at the question again. So the first part was the angle, and then it's the magnitude, which I have, and now the friction. Okay. Let me see what's
R
here.
is the friction.
What is the angle? The angle was 56.31.
Mm-hmm.
What is the magnitude of the reaction force at the base of the ladder? That's the S.
Mm-hmm.
I got that. How much friction does the ground provide? That's actually this one. No, this one here. Can I go down to explain it? Yes?
Yeah, isn't it
Sorry, let me just be clear. So the first one, A, that's here. Yes? And then the B, the net reaction force at the base of the ladder, that's here. This is the B. Yes? Now time for the C part. Can I go down? So what's happened here is, here's your ground. I'll do it in green. That's not green. Here's your ladder. And there's two forces here. There's a reaction force, which we know is or sine theta. Sorry, S sine theta. And the ladder wants to fall this way, doesn't it? But it doesn't fall because there is a friction force this way on the ground. This is S cos theta. So this is what I want to know. So that equals 235.8 cos, what was my angle?
It's 130.8 newtons.
We had it a moment ago?
Yeah.
130.8. Oh, coincident, yeah, of course, the same as the or, of course, yeah. 130.8 newtons, of course. That's the C part. Yeah?
Mm-hmm.
Continue? Okay. I'm going to stop this now, yeah? I mean, do you have all of this? Yes? You subscribe to my YouTube channel?
Yes, yes.
Yes. Google won't let me change the name of my channel until I have 100 subscribers. So right now my name is just, the bunch of letters at the end. And I want to change it to something easy to remember. So it's like youtube.com/channel/ DIFC or something. But right now it's, you know, youtube.com/channels/u1234b1, you know, long thing like that. So I tried to change it, and you're not allowed to change your channel name until you have 100 subscribers.
Okay.
So right now I think I have 42.
52.
That's like
Yeah, it'll be a while, I think. Can I close this now?
Yes.
Yep.